in examination point of view also. Okay, so let us consider first question. So this is first question, means y is equal to a cos log x plus b sin log x. Then prove that x2 y2 plus xy1 plus y equal to 0. So y2 is nothing but second derivative of y, means d2y upon dx2. y1 means dy by dx. Okay, so first we have to show second derivative of this given question, and then by using Leibnitz theorem we will prove yn plus 2. So in each questions, if you have any problem in yn plus 2, means first you differentiate 2 times given question, and then by using Leibniz theorem you differentiate n times, then our problem will be solved. Okay, so this is very easy question. So what is solution? So let given y equal to a cos log x plus b sin log x. Okay, so these are cos like theta. So cos theta, differentiation of cos theta is equal to minus sin theta, and differentiation of sin theta is equal to cos theta. So as you know, if we differentiate this thing, so first we put log x is equal to theta, so cos theta, and then we differentiate again this thing. Okay, so now differentiating with respect to x means dy by dx. So dy by dx is nothing but y1. Okay, so here minus a sin log x, and what is the differentiation of log x? 1 upon x plus b, because b is constant, so sin log x, so cos log x, and differentiation of log x is again 1 upon x. Okay, now by multiplying by x on both sides, so we get x y1 is equal to minus a sin log x plus b cos log x. Okay, now we need y2, so again differentiating with respect to x on both sides. Okay, so again differentiating with respect to x, so we get here again we see here product of two function, means x is first function, y1 is second function. So differentiation of x is 1, y1 as it is, plus x y2. What is y2? Means this is dy by dx, differentiation of dy by dx, so d2y upon dx2 equal to minus a sin log x means cos log x, differentiation of sin x is equal to cos x, and again log x means 1 upon x. Here since differentiation of cos x is minus sin x, so minus b sin log x upon x. Okay, so now again multiplying by x on both sides, so we get x y1 plus x square y2 equal to minus a cos log x minus b sin log x. Okay, so here we see minus is common, so minus a cos log x plus b sin log x. Okay, so here this is again we get y, this is given question y, so this is minus y is nothing but we take one side all the values, so we get x y1 plus x square y2 plus y equal to 0. Okay, so this can also be written as, first we write y2 means x square y2 plus x y1 plus y equal to 0. Okay, so this is the proof of first part. Okay, now we need to show second part. Second part means we need x square yn plus 2. It means we differentiate n times, because we have y2 means 2 times differentiation, and here we need yn plus 2 means again differentiating n times this question. So we get our result. So this is, you remember that when we need yn plus 2, so first you differentiate 2 times and then by Leibnitz theorem you differentiate n times. Okay, so we have Leibniz theorem. So now differentiating n times with the help of Leibniz theorem. Okay, so first we again remind what is Leibniz theorem. Okay, so Leibniz theorem is that if u and v are two functions of x, okay, so differentiation n times means dn uv. So what is dn uv? So this theorem says that first you differentiate n times first function means dn u v as it is, plus n c1 is nothing but n, so n dn minus 1 u dv means first derivative of second function, plus n minus 1 by 2 dn minus 2 u and d2v, plus up to show on last term u as it is dn v. Okay, so this is Leibniz theorem. So we shall use this theorem in given question. Okay, so now here x2 x square y2 plus x y1 plus y equal to 0. So you remember always when we have this type of question, so u and v, so we always take x square x cube means power of x as a second function. Why? Because if we put x square as second function, so here in the formula we differentiate 1 times, 2 times and 3 times, and then all terms will be 0. Okay, so this is very easy to by taking x power n or x square x cube as a second function. So now differentiating n times with the help of Leibniz theorem, so we get, this is the Leibniz theorem. Okay, so here dn u into v means y2 into x square plus dn y1 into x plus dn y. Okay, so I have written here in place of x square y2 is equal to y2 x square. Why? Because we know if we take x square as a second function, so this is very easy to prove. So you always put second function as x square or x cube or x. Okay, so now for first term, so we will use Leibniz theorem for first term. So what is Leibniz theorem? So this is dnu means differentiation of first function n times. So y2 have, so yn plus 2. So this is yn plus 2 second function as it is. Okay, plus nc1 is nothing but n, yn dn minus 1 means yn plus 1, dx square means 2x, plus again n minus 1 by 2. So n minus 1 by 2. Okay. Again, now decreasing first function means yn, and again differentiating 2x, so 2. Now next term will be 0 because we have differentiation of constant is 0. So this is complete. Differentiation of first term completed. Okay. Now for second term means here this is u and this is v. So differentiation of u, so dn u, so this is yn plus 1. Okay. dn u, this is dn u means this is u, so yn plus 1, and v as it is, so x as it is. Okay. Plus nc1 means n, dn minus u means decreasing of first function means dn here yn, and differentiation of x is 1, so there 1, here 1. Next term will be 0 because 1 is constant, so differentiation of constant is 0. Plus dny is nothing but yn equal to 0. Okay, so this is very easy to calculate by Leibnitz theorem. Now we arrange same term. Okay, so here x square yn plus 2 n plus 1. So here n plus 1 and here n plus 1. So plus 2nx yn plus 1 plus x yn plus 1. Okay. Next term yn means 2 to cancel. So plus n minus 1 yn. Here this and this is yn means plus yn and this is last term means plus yn is equal to 0. Okay. So here now we arrange same coefficient term. So this is x square yn plus 2 plus here x is common, so 2n plus 1 x yn plus 1. Here yn is common, so n square minus n plus n cancel, so plus n square plus 1 yn is equal to 0. And his proof, because we need to show here x square yn plus 2 plus 2n plus 1 x yn plus 1 plus n square plus 1 yn is equal to 0. Okay, and his proof. Okay. Now the next important question, if in is equal to dn upon dxn xn log x, means this is given condition, means this is in. Okay, notation of this question, then prove that this in is equal to this thing. So first you see given question in, this is the notation. So here if n, so n derivative, and here n. Okay, if you want I2, so you put in place of n equal to 2, so this is I2. Okay, and similarly what is in minus 1? So if we put n is equal to n minus 1, so we get in minus 1. So proof is very easy. Okay, so we have here given in equal to dn upon dxn xn log x. Okay, so as we know, this is differentiation of this function n times. So we can write this thing dn minus 1 dxn minus 1 and dy by dx. Okay, xn log x means we first differentiate 1 times. So how many time remaining? dn minus 1. So this is dn minus 1 dxn minus 1 equal to product of two function. Okay, product of two function. This is simple. This product of two function only one times differentiation. So first function n x n minus 1, second function as it is plus first function as it is, differentiation of second means 1 upon x. I think this is very easy because product of two function, in case of product of two function, we differentiate first function and second as it is, and then first as it is, differentiation of second. Okay, so now differentiation also possesses property of algebra, means a function of x plus function of x1 plus x2. So we can write here dn minus 1 upon dxn minus 1. This is xn x1 minus 1 log x. Okay, plus dn minus 1 dx n minus 1. This is x to the power n minus 1. Okay, so now this is very easy to see. This equal to n is constant, so we can outside, so dn minus 1 dx n minus 1, and here x n minus 1 log x plus, as we know, differentiation of x to the power n times. So we have dy by dx. If you have n and dn y by dxn, xn is equal to factorial n. Okay, so in similar, if here n minus 1, so this is factorial n minus 1. Okay, now this is very easy. You see given question. So here given question is, here notation of in is dn by dxn, this thing. So this is, if I want to n minus 1, so here put it in place of n minus 1. So this is converted as en minus 1 by given question. So in minus 1, and this is factorial en minus 1, and hence proved. Okay, again a very important question. If y equal to x to the power n minus 1 log x, then prove that dny. Okay, so you see here we need differentiation of y n times. So when you need differentiation of n times and of any function, so you remember Leibnitz theorem. Okay, so solution is very easy. So given y is equal to x to the power n minus 1 log x. Okay, so here we have differentiation of log x is 1 upon x. So first we differentiate 1 times. Okay, so y1 equal to product of two function. Okay, so we will write differentiating with respect to x. So we get y1 is equal to product of two function. So first function n minus 1 x to the power n minus 2 log x as it is, plus x to the power n minus 1, differentiation of log x is 1 upon x. Okay, now since here in denominator x, so multiplying by x on both sides. So multiplying by x on both the sides. Okay, so we get x y1 equal to here n minus 1 x to the power n minus 1 into log x plus x to the power n minus 1. Okay, we need total n times differentiation. Okay, but we have differentiate 1 times. So how many more now need? So we need now n minus 1. Okay, so we will write now differentiating n minus 1 times with the help of Leibniz theorem. Okay, So as we know the formula dn uv, so we will write dn minus 1 uv. Okay, so you will take always when x as a product, so x is a second function, and here n minus 1 is constant, so dn minus 1, this is log x, and x to the power n minus 1 plus dn minus 1 x to the power n minus 1. So here we need some formulas of differentiation. In left hand side no need anything, because dn uv equal to dn u v as it is plus n dn minus 1 u dv. So we shall use this formula in left hand side. So here dn uv, so first we differentiate n times. So in the formula here in place of n is n minus 1. So first dn minus 1 y1 means yn and x as it is plus n is nothing but n minus 1. So n, this is decreasing order means yn minus 1, and differentiation of x is 1, and next term will be 0 because 1 is constant. So in left hand side this is complete differentiation. Okay, is equal to n minus 1 is constant. So here you see product of two function log x and x to the power n minus 1. So here we take n minus 1 as a first function. Why? Because n minus 1, so dn minus 1, here x to the power n minus 1 we will take first function because log x, and here formula dn xn is equal to factorial n. So in place of n is n minus 1, so we will write here n minus 1. Okay, now this is n minus 1 first function, n times means n minus 1 times, so this is factorial n minus 1, and this is as it is. Okay, now also this is very easy to see, this is y, so no need to differentiation. Okay, this is y, so no need to differentiation, we will put directly in place of n minus 1. Okay, so this is very easy to see, don't differentiate this thing. So here yn x plus n minus 1 yn minus 1 equal to n minus 1, what is this? This is in minus 1, because here given y is equal to x to the power n minus 1 log x, so this is yn minus 1. Okay, plus factorial n minus 1. So here yn minus 1 y, this is cancelled, so x yn is equal to factorial n minus 1. So dny is nothing but yn is equal to factorial n minus 1 upon x. So yn is nothing but dny equal to n minus 1 factorial upon x, and hence proved. Okay, so this is the solution.